Now we're going to start looking at some partial fraction decomposition problems. And for the most part, what it's going to look like is you're always going to have something that's of the rational functions. That means it's a polynomial on the numerator and polynomial on the denominator. And what you're going to do is, first you want to take the integrand here. And you want to factor the bottom if it's possible to factor. In this one, it does factor into x plus 5, x minus 2. And what you want to demonstrate and what you want to split it into is you're sort of reverse adding the fractions. You're trying to make it over a over x plus 5 plus b over x minus 2. Okay, so if I have two different factors and I want to split it into the fractions. Now, a lot of times you usually go the other way. You're usually given this side and we add it by making a common denominator and putting it together like that. But here we're going to do the kind of the reverse. And the way you're going to do this, you're going to say like, well, if I want to figure out what a and b are constants. I want to add this side. That means this side, in order to combine it into a single fraction, x plus 5, x minus 2, I would have to multiply a by x minus 2 and multiply b by x plus 5, right? And so I look at this equality and I say, well, this part, this numerator has to equal this numerator. And then I want to solve for a and b. Now, in order to make these equal, I take everything with an x in it. So if I were to distribute everything, I would have ax minus 2a and bx plus 5b. So everything with an x in it, I would have a times x. And with it here, I'd have a b. And then the constant terms without x, I would have a minus 2a, and I have a plus 5b over here. And that would equal 7x plus 7. And in order for these two to be equal, a plus b, this would have to be 7, and this would also have to be 7 to make both sides equal for all values of x. So I have a plus b is equal to 7, and then minus 2a plus 5b is equal to 7. And you can do this however you like. I tend to do elimination method is my favorite, so I'm going to double this one to make it 2a plus 2b is equal to 14. Then when I add these two together, these cancel. I get 7b is equal to 21. So that means b is equal to 3. And because a plus b is 7, that means a has to be 4. So then this, I know, becomes the integral of 4 over x plus 5 plus 3 over x minus 2, because that's what a and b were, dx. And these are each natural log, right? This is 4 natural log, so value of x plus 5, plus 3 natural log absolute value of x minus 2, plus c. Okay. Let's look at this one here. So similar thing here, I'm always gonna factor first. I'm gonna do negative 4. On the bottom, I can factor out a 3. It's going to become x squared minus 4. And then that will factor into x plus 2, x minus 2. Okay, and then that I know is equal to a over x plus 2 plus, plus b over x minus 2 as an example. And that's equal to a x minus 2 plus b x plus 2 over x plus 2, x minus 2. Okay, and so I know that this negative 4, there's a couple ways you could do this. You could either bring out these constants in front and then just make this 1. I'll just make it negative 4 and then bring the 3 out in front. So we're going to have negative 4 is equal to a x minus 2 plus b x plus 2. And so if I take out all the terms with x, I'd have a plus b here. And then my constant term is going to be minus 2a plus 2b. Now this one has to be 0, and this would have to be negative 4 in order to make both sides of the equation equal. So I have a plus b is equal to 0. And then negative 2a plus 2b is equal to negative 4. So if a is equal to, this is a is equal to negative b, so this becomes 2b plus 2b equal negative 4, or 4b is equal to negative 4, b is equal to -1, and therefore a is equal to 1, because 1 minus 1 would be 0 here. So then this, if I take out the 3 here, because I excluded the 3 from all of this process, becomes the integral of 1 over x plus 2, because I found a was 1, minus 1 over x minus 2, because b was -1 dx. And so then this becomes 1/3 natural log absolute value of x plus 2 minus natural log absolute value of x minus 2 plus c. If you wanted to, you could do your log rules. So this equals 1/3 ln. When I subtract two logs, I divide it, x plus 2 over x minus 2 plus c. Technically, it's the absolute value there. Okay? Number 3. So here we have a repeated root when we do this factoring. This x plus 7, it's really x plus 5 times x plus 5. Now you can't make it equal to a over x plus 5 and another x plus 5. That wouldn't make any sense. It actually wouldn't work. The only way this can work out is there's another term, b over x plus 5 squared. And this is how you deal with repeated roots. If I ever have repeated roots in the denominator, I put if it was cube, I would have a linear term, a square term, and a cubic term. Okay, so in this case, this is a repeated root of x plus 5, repeated factor. So I do an x plus 5 on one and an x plus 5 squared on the other. Now this one, in order to make everything over x plus 5 squared, what I would do is this one just needs to be multiplied by x plus 5. But this term's already over x plus 5 squared, so I can just leave that alone, right? And so then I have x plus 7 has to equal this ax plus 5 plus b, because the denominators are already the same, and so just the numerators have to match for them to be equal. And so this is x times a plus the constant term, which is 5a plus b. And so that tells you this has to be 1 and this has to be 7. So a is equal to 1, and then 5a plus b is equal to 7. This is 5, so that makes b is equal to 2. So then when I do this integral, I'm doing the integral of, let's see, 1 over x plus 5 plus 2 over x plus 5 squared dx. Okay. Now, this one is natural log. This one, if you think about it and you do u substitution with u, this is really 2 times this to the -2. And so this one I would write as 2x plus 5 to the -1 divided by -1 plus c. And so this would be ln absolute value of x plus 5 minus 2 over x plus 5 plus c. Because if I took the derivative of this one, hopefully you'll see that you'll just get this term here. The derivative of this, I would just have -2 over x plus 5 squared. Okay. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.